Welcome back, dear students and viewers. So we are continuing with the discussion on properties of hydraulic oils. So we have started with the important properties like viscosity, density, and we have discussed about viscosity index and its variation with temperature, etc. So we'll continue the discussion today, and we will try to wind up the properties, and we will try to summarize. Okay. So without any delay, we'll move on to the next property.
Once again, these are the reference textbooks. So most of my lectures will be based on these textbooks. So the fourth property to name is a thermal expansion of the hydraulic fluid. So as you all know, hydraulic oils when used in a hydraulic system is subjected to volumetric thermal expansion. So thermally it will be expand when the temperature changes. So thermal expansion means when there is a temperature variation, the volume of the oil may or may not change. So it will purely dependent on the type of the oil employed. So the variation of temperature with respect to volume is expressed as delta Vt is equal to alpha V delta T. So what are these terms is clearly explained here. V is the initial volume. Delta Vt is the volume change due to thermal expansion. So whenever there is a temperature change of delta T, how much volume is changed is denoted by delta V subscript T. Subscript T stands for temperature or thermal. Alpha is a coefficient, thermal expansion coefficient in 1 by Kelvin. Delta T is the change in temperature in degrees Celsius or Kelvin. Okay, so this is a relation between the volume change with respect to temperature change. So what are the effects? Suppose the hydraulic oil is trapped in a rigid vessel for a longer period of time. Suppose the system is not in use for a longer period of time. The pressure, since it is pressure rigid vessel, may increase due to the rise in oil temperature, right? If the hydraulic oil is trapped in a rigid vessel. So this will lead to the problems in the operating hydraulic system. So much of problems, material effects, so many things will be there. The properties of the oil may change, right? So all these are the effects of thermal expansion or volumetric change due to temperature change. Okay. Now the next property is vapor pressure. I think we have discussed in the first module fundamentals of fluid mechanics, right? So it is the pressure at which the liquid, here in this case it is oil, will boil, change its phase from liquid to vapor. So when the oil temperature increases, the vapor pressure of the oil also increases. So what is the effect again of vapor pressure? It is none other than the cavitation. What is cavitation? When there is a fluid flowing in a conduit, okay, whenever the pressure drops below the vapor pressure, fine, drops below the vapor pressure, vapor bubbles or air bubbles will be formed. These bubbles will carried away along the flow, and whenever there is sudden rise in pressure at some locations of flow, whenever there is some sudden rise in pressure, what will happen? Obviously, these bubbles will collapse. And due to that very high increase in pressure, and there will be a lot of damage in the conduit where the fluid is flowing. Especially this is important in the case of turbines and pumps. So ultimately, the effect of Cavitation is the erosion of hydraulic elements, various elements, wherever this cavitation occurs. So cavitation in short is the formation of bubbles at a low pressure region and bursting of these bubbles causing very high pressure variation, pressure rise, and erosion and damage, very high noise in these hydraulic elements or components. So how to avoid that is to maintain a pressure well above the saturated vapor pressure. So that is important to avoid cavitation. Now the next property is the lubrication and anti-wear characteristics. So what is lubrication? The movement of the interconnected parts should be smooth without any friction or wear. So ability of the hydraulic oil, it is an ability of the hydraulic oil used to cover the contact surfaces. So the contact surfaces, in order to avoid friction or wear, we should cover the surfaces with a thin layer of oil. So that is a property inbuilt with a good hydraulic oil. You don't need to use a separate lubrication oil. Hydraulic oil itself will provide a good lubrication, or it acts as a lubricant. If the thin film is destroyed, what will happen? Due to low oil viscosity, suppose the viscosity is low, so it will flow quickly, right? So the oil formation will not happen, will not take place. So very high loading or poor supply of oil, if the supply of oil is not adequate, so there are chances of wear due to fretting. So there should be good properties or quality oil in the hydraulic system in order to provide a better lubrication between the moving parts. The lubricative power and film strength of a liquid are directly related to its chemical nature. So the chemical nature of the oil should be thoroughly understood and employed in the appropriate applications. So along with the lubrication, another property mentioned here is anti-wear characteristics. So the wear can also happen due to not only due to friction, due to fatigue, abrasion, as well as corrosion. So all these should be avoided with the use of proper hydraulic oil. Compatibility, which is the seventh property. So hydraulic oil must be fully compatible with other materials used in the hydraulic system, such as those used for bearings, seals, paints, etc. So all the hydraulic components with which the hydraulic oil comes in contact should be secured. That means the hydraulic oil should not cause any effect on such components such as bearings, sealants, seals, paints, so especially this plastic components. If it is there, rubber components may be there. So no chemical reaction should happen between the hydraulic oil and these components. Also, the oil must be compatible with the mechanical and electrical components also. Since in case of leakage, the oil will get in contact with this and it will cause a adverse result or hazard. So compatibility issues are very important. So the selection of hydraulic oil is finalized based on the compatibility of different materials with which it may come in contact in case of leakage also. So that also should be studied carefully. Suppose leakage happens, hydraulic oil, what are the chances of hydraulic oil comes in contact with the other components, which are the components, and if there is any chemical reaction with this. Chemical stability. This is the definition of chemical stability. The ability of the liquid to resist oxidation and deterioration for long periods. So it should resist oxidation as well as deterioration for a longer period of time. A good hydraulic oil should not be oxidized too quickly or deteriorate too quickly. Some metals such as zinc, lead, brass, copper have undesirable chemical reactions with certain liquids or hydraulic fluids. So these reactions will result in the formation of sludge, gums, carbon or other deposits, so which will cause the valves and pistons to stick together. The movement will be affected. So chemically, the oil should not react with any of the metals or the materials of the hydraulic components through which the hydraulic oil is flowing or comes in contact. So oxidation inhibitors could be added as an additive to improvise the stability of the chemical stability of the hydraulic oil. So towards the end, we will discuss about the additives as a separate section. Oxidation stability. Already we have seen that it should resist oxidation, right? So again, we studied as a separate property. It is the ability, oxidation stability is the ability of the fluid to resist chemical degradation by reaction with atmospheric oxygen. So whenever the hydraulic oil is in contact with atmospheric oxygen, it should not react with it and form a oxidation layer. So it is very important for high temperature applications. So it is a matter of aging, resistance to aging. So the effect of oxidation, if suppose the oil is oxidized with reacting by reacting with atmospheric oxygen, what will happen? There will be significant rise in viscosity, development of corrosive organic acids, and lagering of critical surfaces by resinous oxidation products. So these are the effects of oxidation stability. The 10th property is formation of forms. So at high temperature and low pressure, the dissolved air in the hydraulic oil, sometimes there could be some dissolved air in the hydraulic oil. So when the temperature is very high and the pressure is low, this oil in the the air in the oil will get liberated, evaporate. This air exists as discrete bubbles in the fluid. So at the top or inside the fluid, it will exist as bubbles. So when the fluid returns to the tank or vessel after performing its function in the conduit, this entrained air bubbles will be there. The air rises to the surface. So from the inside of the fluid, it will rise to the surface and create foam. You might have seen in some liquids on the top of it, some air bubbles are floating like a foam. So that is the effect of dissolved air in the liquid. It can cause severe problems in the hydraulic system. So especially when we consider the hydraulic system, it can cause severe problems. So therefore, most hydraulic fluids contain foam depressant additives that cause rapid breakdown of the foam. So again, some additives, if there are chances of formation of foam, air bubbles coming to the surface and forming the foam because of the temperature and pressure variations. So it will purely depend on the application. If such an application, if there are chances of very high temperature and low pressure, so appropriate additives to break down the foam or air bubbles will be used. So very important property, cleanliness of the hydraulic oil. It needs special attention in selection of hydraulic oil, especially in aerospace applications. This military and aerospace applications, it is very true. The contaminants in the oil cause malfunctioning of the components, increase in wear, improper valve seating if there are foreign particles. So the narrow gaps or clearance between the moving parts like valves and all get affected If the valves are not getting seated properly, it will affect the movement of the operation of the valves as well as movement of the piston and all. Also, it may increase the response time. So entirely it will affect the entire system. Many contaminants, foreign particles like air, water, solvent, any other fluids, all these are the other contaminants affecting the cleanliness of the hydraulic oil. Thermal properties. There are multifold thermal properties: power point, flash point, fire point, specific heat capacity, and thermal conductivity. These are the desired thermal properties of a hydraulic oil. So power point is a temperature 3 degrees Celsius above the temperature at which the fluid ceases to flow. It is a temperature above a particular value at which the fluid ceases to flow. It will stop. It will not flow at all. That is a power point. Flash point is the temperature at which the liquid gives off vapor of sufficient quantity to ignite momentarily or flash when a flame is applied. Suppose we are applying a flame to the fluid. Suppose there is some fire hazard. Okay. If the temperature of that fire is good enough, the liquid will gives off the vapor of sufficient quantity to ignite momentarily or flash. So the liquid may ignite it and get burnt when the temperature is reached at the flash point of that particular oil. Fire point. The temperature at which a substance gives off vapor of a sufficient quantity to ignite and continue to burn. So you should understand the difference between flash and fire point. Flash point is it is momentary ignition. It will just ignite or flash, but it will not continuously burn. It will not continuously burn when the temperature is reached at flash point, but it will continue to burn when the temperature is reached at fire point. And specific heat capacity, it is the quantity of heat required to raise the temperature of 1 unit of mass of a substance by 1 degree with unit kilojoule per kilogram Kelvin. And the last thermal property is thermal conductivity. It is the ability of a material to conduct heat by close contact or between the molecules which are in contact each other, expressed in watt per meter degree Celsius or watt per meter Kelvin. It is especially important in the heat transfer. We will have another important, separate session on heat transfer on a later stage. Okay, I will try to prepare a session on basic heat transfer mechanisms and the properties. It's a separate module. Okay, you can watch that later. Next property number 13 of the hydraulic oil is acidity. So what will happen? The acid content of the hydraulic oil, it may cause corrosion of the metals in the system. Acid content will lead to corrosion of the metals. In the initial stages, all the hydraulic oils may not be acidic. But when the oil starts deterioration, the oil may become corrosive on usage. So next property is the toxicity of the hydraulic oil. The quality, state, or degree of being toxic or poisonous. That is the definition of toxicity. It is the quality of the oil of being poisonous. So chemicals, again, The chemical composition of the oil will determine whether it is toxic or not. The chemicals contained in the hydraulic oil may be poisonous in nature and it will cause the effect. So these toxic or poisonous chemicals may enter the body through inhalation. So it is very, um, it will cause very severe effect on the persons who are working in close with the hydraulic systems. Suppose these toxic chemicals, poisonous chemicals, entered into the body through inhalation or by absorption through the skin or through the eyes or the mouth, it will have very bad effect or adverse effect in the systems of the human body. So most of the manufacturers of hydraulic liquids try to produce suitable liquids that contain no poisonous chemicals, and as a result most hydraulic liquids are free of harmful chemicals. So that is another, this toxicity content of the hydraulic oil is another important parameter of the environmental compatibility also. So in the next session we will discuss about the various types of hydraulic fluids used, such as mineral oil, synthetic oil, fire resistant fluids, etc. Okay. So till then, goodbye. If you have any doubts, please comment below and please provide your feedback. Don't forget to subscribe to get the updations of the all the videos. Thank you.